This is my misinterpretation of a Joule ringer. No, but seriously. What I did was added iron oxide onto the one half of the toroid. See if it's easier to create so much magnetism and send it through the smaller part of the core on the secondary. Can we get any kind of gain out of it? So the primary coil is bifilar, and that's the Joule thief circuit, and the secondary, which is isolated, that's half as many turns as the primary, but it's a heavier gauge wire. I have a pot in series with the power supply, and I have the milliamps gauge here so we can see what's going on with this. The secondary, I have the piezo buzzer connected up, and I also have in parallel these two LED lights. What I want to show you here is how that piezo buzzer can tune the circuit just from a reflection of the sound wave as you put your finger in front of it. I think you can see the lights there are also affected. You can see the gauge is also changing there. So it's affecting the power going in. I can tune this, changing the pot, how much power is going in. Depending where you tune it, the piezo buzzer doesn't respond. We get a reflection of the sound wave going back through. These piezo buzzers are used as a speaker, but they can also be used as a microphone, so you can get the feedback on it. The other thing I want to show here is I'm going to flip these LEDs power supply around. And since they're diodes, they're controlling the direction of current in the secondary when it's under load. Watch what happens when I connect this with the LEDs. It goes in the right direction and pulls off of the primary, and it also drops the power input. Here I have 15 LEDs in parallel on the secondary of this Joule thief, and I'm not using the buzzer this time. I'm going to explain something first about these fluorescent bulbs. When I was doing experiments with the Scalar exciter, there's a vortex that you can see inside these bulbs, and you'll see these pulses going in one direction. As you increase the power in the Scalar exciter, those pulses will stop, and if you keep increasing it, they'll change direction. That's something we're going to see in this Joule thief. Right now the milliamps is at 9.5. When I connect up the secondary LEDs, it goes to 10.5. So we only have 1 milliamp increase. There is a slight dimming of the primary. Now as I turn this pot up, the current increases going in from the battery, and this gauge is going to max out. But then there's a shift that occurs, and the primary then goes dim and the secondary is brighter. Right about there is where we have that pulse wave that stops. Now we're on, have the wave going the other way, and the primary is brighter. And we'll shift it the other direction. Now the secondary is brighter. I think I made a mistake on where that stationary wave point would be. This gauge wasn't able to go high enough, so I took out some of these LEDs. I now have 8 of them in there, so now the meter will stay in range. And right now I have it at that point where the stationary wave would occur. Before I had it on the low side of the one side of the wave. So we increase it until we hit that maximum. Right where that shift point is on the high side is where it would occur. Now we're on one side. There's a shift point. Now we're on the other side. I'll turn it up to that shift point, and that's where we get the maximum power on the primary and secondary. When we pass it, it shifts the other way. Thanks for watching.